Binomial products. The word tells you what it's talking about. Binomial. Bi, of course, means two. Two. See if I get away with this. Nomial means terms. I don't know. But basically we've got two terms, things with two terms, binomials. Our products, and we're going to multiply them together. So we're basically saying we've got things with two terms and we're multiplying them together. So something like that. You recognise that sort of question. See, inside both sets of parentheses, and they are called parentheses, they are not called brackets, they are parentheses. If your English teacher ever says, have a look at what's in the brackets, correct them. Sorry, they're parentheses. X plus 6 times x plus 1. And look, I've seen many different ways of people learning how to do this. That's probably the most common one is the FOIL method. You get taught that one, first outside, inside, last, that idea. That's probably the most common method. I use the face method. Let me show you the face method. So you physically draw the line in. It's sort of like the FOIL method, but I'm drawing the line in. So I go, okay, x times x is x squared, outside, or x times 1, that's x, inside, 6 times x is 6x, outside, 6 times 1. And look, you're drawing a face. See, the two inside parentheses become the nose, the outside parentheses is the ear, you've got a lovely smile and some eyebrows. X squared plus x plus 6x plus 6, group your like terms, and there's your answer. Okay. That's the face method. Mathematics can be described as the science of patterns. And we look for patterns. We spot a pattern, we solve a problem. Because the beautiful thing about maths is if we spot a pattern and we can use it again and again and again and again, it saves time. In fact, we will spend an amazing amount of time looking for a simple pattern. But we only have to use that amount of time once. Because once we've got the pattern, we solve the problem. So this type of question comes up so often. A plus b squared, we see the pattern, we know the pattern. It's a squared plus 2ab plus b squared. We can do that straight away. The negative one is similar, except it's minus 2ab. So in general, I don't know if you knew this or not, in general, you don't have to have a binomial. You can have as many terms as you like. So if you've got a plus b plus c plus whatever, going up squared, what you end up with is every single one of them squared plus twice every possible combination of two of them. So a times b, a times c, b times c, whatever else is there, a times c. Every possible combination, there'll be two of them. Our difference of two squares, that's the other one we see a lot. So a plus b, a minus b. Okay, let's do some examples. Knowing that then, x plus 2 squared, now I'm not saying you would write this line down, but in your head you're going, oh yeah, that's right, a squared plus 2ab plus b squared. So I've got, yeah, that's a plus b squared, that's a squared, that's 2ab, that's b squared, you go and work it out. Reality is you probably just write that line down, x squared plus 4x plus 4. A negative one then, so yeah, right, we just write it down. Bang! A squared minus 2ab. Well, twice 4 threes, that's 24. 16. Difference of two squares. Okay, 4p squared minus 25. See, that's what I mean. Spot the pattern, answer comes out quicker. Oh, something a bit different. Because the second one's a trinomial, not a binomial. Haven't got a formula for that. This is where, again, I draw lines to make sure I'm including everything. So I've got 2 terms times 3 terms, so I know I should end up with 6 terms. That's a way of keeping check that I've expanded it out properly. But that means I have to a times the first one, then the second one, then the third one. Okay, but then the second. Ooh. There it is. Done them all. I've made sure I've got everything times everything. Collect like terms, there's our answer. Okay, this is a technique you will probably never have seen before, and to be honest with you, I only saw it a handful of years ago when I was reading a textbook written in the mid-1800s. But this is the method. So if I've got to multiply this times this, here's how I do it. First of all, you list all of the coefficients of the first factor starting with the highest power. Now, you'll notice I've written a 0 there because there was no coefficient of x. So they're all there, I just can't see them all, so I write 0 down. That's the first thing. Then I will list all the coefficients of the second factor, starting with the highest power, but there it is. Notice I have not lined up the cube with the cube and so on. So we just line up that way. Okay. Multiply all of the first row by the first number in the second row, writing the first result under the first number. So everything's being multiplied by 3. 3 times 2 is 6. 3 times -4 is -12. 3 times 0 is 0, and so on. But now we'll multiply all of the first row by the second number in the second row, but we write the first answer under the second number. And then we keep going. I'll now multiply all by the third, but writing it under the third number. Now we simply add down the columns, and there's the coefficients of your answer. Starting with the highest power, and the highest power, remember, will be the highest power times the highest power. So x cubed times x squared is x to the 5. That's where we're starting. There's my answer. Done. Do I use it? I probably don't, if I'm honest, because I'm too old when I first saw it. I'm just so used to doing it the other way. But it's not bad for some of those longer ones. Let's try this. Same one, same idea. Now, I'll put the bigger one on top usually. So it's got 3 terms. So 1 minus 3 is 7, and 1, 2. Multiply everything by 1. Multiply everything by 2. Add them together. The highest power on this one should be cubed. There's my answer. Done. In fact, you could do ones like this. The x and the y are sort of irrelevant. I'm only interested in the coefficients. So write down the coefficients. Remember, there's a missing one there. There should be an xy where they're both to the power of 1. Because with this one, you'll see the pattern. Powers of x are going down by 1. The powers of y are going up by 1. But they always add to give 4 in each of the terms. And in the second one, same sort of idea, but now we're starting at 2. Therefore, there's a missing middle term where both x and y were to the power of 1, because that would have added up to 2. Add them up. There we go. What would the highest power be? X to the 6. Whoop, hang on. Whoop, there we go. X to the 6, there's our answer. Start at the 6, powers of x are going down by 1, powers of y are going up by 1. Bingo! So yeah, okay, on the really small ones, it might not be a great method, but you get a question like that, how much quicker is that than expanding the whole thing out? Okay, came across it in a really old textbook, thought, that's cool. 1B.